Find the probability of the indicated event if P of E is equal to 0.25 and that P of F is equal to 0.45. A. Find the probability of E and F if the probability of E or F is equal to 0.6. So for these problems, we're going to use the general probability rule. So the probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. So using the general rule of addition, right, the general probability rule for addition, we're simply going to make an equation and solve for the missing variable. So for A, we're using the information from above and the information given. So we're looking for the P of E and F, so that's going to be our variable. It says the P of E or F is equal to 0.6, so we're going to say 0.6 is equal to the probability of E, which is 0.25, plus the probability of F, which is 0.45, minus the probability of E and F, and that's what we're looking for, right? We're looking for the probability of E and F, so that's going to be our X. So then it's just basically an algebraic equation. We have to get X by itself. So what I'm going to do, I'm going to add 0.25 and 0.45 together. So I get 0.6 is equal to 0.7 minus X. I'm going to bring 0.7 over by subtracting 0.7 from both sides. That leaves me with a negative 0.1, which is equal to negative X. Can't have a negative variable, so you divide by negative on both numbers. Divide by negative 1, divide by negative 1. X equals 0.1, which is the same thing as saying the probability of E and F equals 0.1. Okay, so we're going to do this again. We got another thing coming, right? We got B. B is using the definitions of some things. So let me erase this. B. Find the probability of E and F if E and F are mutually exclusive. So this one is a definition type of a question. To be mutually exclusive means they have nothing in common. If there is nothing in common, then that means there's no intersection. And if there's no intersection, then the probability of E and F is 0. So there's no math involved. It's simply knowing the definition of mutually exclusive. Now, for C, we need to find the probability of F complement. To find the probability of F complement, we'll simply use the formula. Probability of F complement is equal to 1 minus the probability of F, which is the same thing as saying 1 minus 0.45, which makes the complement equal to 0.55. So then the probability of F complement is equal to 0.55. And the last problem. So we got new definitions now. So we're not going to use these previous numbers up here. For D, we're going to use this new information. But we're going to use the same general addition rule. New numbers. So then the probability of F is equal to 0.3. Probability of E or F is equal to 0.65. the probability of E and F is equal to 0.15, we need to find the probability of E. So again, I'm going to replace the numbers where they go. So 0.65 is equal to probability of E, which we don't know, so that's going to be our X, plus the probability of F, which is 0.3. Erase that. Sorry guys, my 3 is just not working today. There we go. Minus their intersection, which is 0.15. So again, we have to get X by itself. I'll combine my like terms, so I'm going to add 0.3 with a negative 0.15, or I'm going to subtract 0.3 from 1.5 or 0.15. So then I get X plus 0.15 is equal to 0.65. Get X by itself, subtract 0.15 from both sides. So then 0.5 is equal to X, which is the same thing as saying the probability of E is equal to 0.5.